Hello and welcome to this presentation related to product design specifications. This presentation builds on a previous presentation where we outline a proposed structure for a product design specification, PDS for short, and considered an array of customer requirements that might be included within such a specification. In this presentation we're going to apply the structure and the knowledge and on which we will develop a PDS for the Tiddlywink Integrated Tester. This is obviously a light-hearted approach to developing PDSs, but hopefully will outline the application of the structure and requirements from the previous presentation. I chose to use the topic of tiddlywinks because people suggest I could be a good tiddlywink player because I'm often referred to as a proper winker. Well, at least I think they say winker. So here's a brief recap. This was the table of contents from the previous presentation, where essentially we outlined the customer requirements stated within a PDS. We stated some general guidelines for preparing a PDS, and then we outlined a proposed structure for the PDS. A considerable array of design requirements were also outlined within the previous presentation, criteria ranging on this slide from labelled 1 performance through to 14 packaging. Requirements considered here from 15 manufacturing facility through to 32 disposal. Finally, from item 33 here, public acceptance, through to 39, quality assurance. This is just a recap from the previous presentation. We also outline what's termed a checklist for the main sections of a product design specification. This is essentially a structure that's proposed in a relevant standard, and we're essentially going to use the essence of this proposed structure to develop our PDS related to the Tiddlywink Integrated Tester. This is the first slide of the structure, and here's the second slide. So what I will show you now is the product design specification I put together for our Tiddlywink Integrated Tester. I'm actually going to display 2 pages of the PDS onto one slide, purely for convenience. This might mean the text on the slide is slightly difficult to read, but for anybody that does actually want to read the specification in more detail, I'll show an enlarged version of the PDS towards the end of the presentation. Notice we next have some important information associated with the PDS. We have the company or the client, Tiddlywinks are us in this case. We have the reference number of the PDS that we can refer to within other documents as required. We have the date of the first issue of the PDS, and we have the effective author of the PDS. So this is all on what's termed the title page, and this is very important information that we would add to the title page. Then we have what's termed the amendment box, where we state various issues of the PDS. Obviously the first issue relates to its first release. We have the date of the release, and we have the engineer that developed the PDS originally, probably in conjunction with many other people. Then notice we have further issues, issue 2, issue 3, through to issue 6. And the object of the issue box is to make engineers aware of the changes. For example, issue 2 suggests it's more of a typographic error. So this is obviously for clarification. So the engineer may not want to read any further than that particular section because nothing else has changed in the specification from the first issue. Issue 3 states that the bibliography has been updated, and issue 4 states that the appendix has been added. So again, an engineer might want to browse those changes just to see if there is any impact on the design specification for their perspective. And issue 5 essentially seems to have a clarification of criteria designation, and it has a section added. So that would be important for the engineer to read. 6, again another section added, so the engineer should review this update. So again, you can see the benefits of having the issue box and the brief comments associated with each change in issue, because it allows the engineer to decide whether they need to read the specification again in its entirety or in part, or to ignore the current issue. So amendment boxes are particularly useful to include within your PDS. Sometimes they might be on the front cover as shown here, but more often they'll be shown on their own separate page following the front cover or the title page. On the right hand side here is page 2 of the specification. And note that at the very top of the page here I have what's termed the header of the document, and at the bottom I have the footer. Essentially the header of the page contains the information from the front page or title page, product design specification for the Tiddlywink Integrated Tester, We have the report number here and the issue of the report, and we have the compiled by, also of the report at this stage. And at the bottom I've included the name of the word processing file that I used here for this particular version of the PDS, and also the page number. So after the title page or the front cover, every page will have the header and the footer associated with it. And this is for traceability purposes, to allow engineers to be aware that they're using the most updated issue of the PDS. I will not show the header and footer on following slides, just to save space for presentation purposes. But as I say, the header and footer is included on every page of the PDS after the title page. So on page 2 of our PDS, we have what's termed the scope. We discussed the purpose of a scope in our previous presentation. Often a PDS we're developing is based on a previous PDS. So a scope is a way of highlighting any peculiarities, any specialist requirements, so that somebody using the PDS will be aware that there are certain aspects, certain requirements that are specific to the previous design, and they may not be required in the new design that's been proposed here. Next we have a circulation list. This should include all stakeholders of the design and development process. The PDS is the foundation to all design work, so it's important that all stakeholders associated with the project are working to the same and current product design specification. These days, of course, design projects can be of global nature, so people working around the world on the same project. For examples are in the aerospace or automobile industries. So we need to ensure everybody has up-to-date information associated with the PDS. So page 3 includes the table of contents. This is fully automated. I did not type this information in. I've used headings throughout my word process document. So this table is generated by the word processing package. It allows for easy updating, but it shows the full structure of the PDS, and that's in line with the structure we outlined in the previous presentation. On the right hand side, section 1, as it's labelled here, this is actually page 4 of the PDS, and the forward essentially outlines the background to the PDS that sets the scene for the various stakeholders working on this project. Just note, in this case I did use AI to generate this forward. So the list of references shown here are generated by the AI package. So at the bottom of the page here, for reference, I've stated the AI package used and some information about how this forward was generated using the AI software. AI can be very useful in helping to develop certain parts of specifications or technical reports, but it's imperative that the engineer clearly reads and modifies the AI generated text as required, and it's important that the engineer does not use AI to generate information that's outside their sphere of knowledge, so that erroneous information is not used within a PDS. And I have checked the accuracy of the forward as generated by the software. And just notice at the bottom of the forward, I did refer to the appendix that occurs at the rear of the PDS, should the reader require further detail related to the game of Tiddlywinks. Here are pages 5 and 6 shown on this slide. On the left hand side, page 5 of section 2, the introduction. The introduction essentially introduces the PDS and states the objectives of the PDS. Section 3 is a list of acronyms that are used within the PDS for ease of reference, and section 4 are specific definitions that are used within the PDS. So I'm highlighting some terms here that will be used within the specification. Because it's a specialist sport, not everybody plays Tiddlywinks, I define such terms as the squidger, tiddlies and the winker, purely again to aid the stakeholders' understanding of the PDS. Page 6, section 5 here, contains the references, and I've actually included my references in this section. In the proposed structure, it was more of a statement of policy of the references. So here are all the references that are used throughout the specification, and it's imperative that the design engineer, indeed all stakeholders, have copies of all these references, because they will be stated in the specification and they have to be complied with. The reference is a very important section to review, and of course in real life specifications the references may span several pages of the PDS. Here is page 7 and page 8 of the PDS. Page 7 contains section 6, which is titled Design Criteria. This is actually the main body of the PDS. This contains all the relevant criteria, relevant requirements that all stakeholders have to comply with, and this is the foundation of all the design and development work from here on in. So what I've done here is extracted what I think are the main design requirements associated with the Tiddlywink Integrated Tester, and they're in no particular order, although I have started with section 6.1 performance. Performance is one of the design criteria that I think should be at the front of the specification. So this is a Tiddlywink Integrated Tester, so we're testing the pots and the squidgers. So I've given some specific dimensions here, stated tolerances, etc., outline various aspects of the performance of the Tiddlywink Integrated Tester. So page 8 on the right hand side here, section 6.2 states the market for which the Tiddlywink Integrated Tester is being designed. Section 6.3 relates to materials, it's very generic here. And then section 6.4 outlines ergonomic considerations and requirements. And just note, for a point of convention, when developing PDSs, we've got various heights and diameters stated in millimeters for our pot, but also stated in inches here. And you can see the same for the size envelope on page 8. Within ergonomics, we state the size envelope firstly in terms of millimeters, but then again also in terms of inches. So that's often a convention that's used within product design specifications. Note within each of the clauses, the term shall or should is used. So section 6.1.1, the tester shall be capable of. Section 6.1.2, the tester shall be capable of. 1.3, shall used again. 1.4, shall. 1.5, shall. Notice in section 6.1.6, it says there the tester should be capable of. In our previous presentation, we highlighted the difference between shall and should. Shall is essentially a mandatory clause. The design engineers and the various stakeholders have to comply with a shall clause. But a should clause is more of optional. It highlights a customer or client preference, and thus is a requirement that should be endeavoured to be achieved, but it's not considered to be mandatory for the final product. And of course, all sections or clauses stating requirements use a shall or a should term. This slide shows pages 9 and 10 from the PDS. On page 9, 6.5 is aesthetics. This relates to the appearance of the product design specification, the style, the colours, etc. Again, referring to the height of the Tiddlywink RS logo. The height of the text is stated both in millimeters and inches again. 6.6 is cost. We have our target costs, profit margins here. 6.7 is weight. And notice that the weight is specified in the SI base unit of the kilogram and also in the imperial unit of the pound. There is a slight issue here with the weight being specified in kilograms. We know from our previous SI unit presentation that weight in the SI is actually in newtons. It's a force unit. The kilogram is the base unit of mass in the SI. But unfortunately, you do find that mass and weight are conflated within such documents as specifications. So the engineer needs to be aware that if we are designing with the weight of 0.5 kilograms, we will need to convert that into newtons at some stage if we're undertaking a stress analysis, etc. within our design work. But just be aware of that fact. And just note for reference, I've included weight here in this PDS as its own section, but sometimes weight is included within the ergonomics section because ergonomics relates to ease of use. And so weight may be a factor associated with ease of use, something that's particularly heavy might be difficult to move or might have safety concerns associated with it. So sometimes weight is included within other criteria. Section 6.8 is reliability and repeatability. Obviously that's important for our Tiddlywink Integrated Tester. And section 6.9 relates to maintenance. Again, something we need to consider up front in the design process. Some products require significant maintenance, so we should design for that, we should account for that in the initial design process. But in this particular instance, for our Tiddlywink Integrated Tester, it's preferable if it's designed to be maintenance free. Page 10 on the right hand side, we have health and safety requirements. Notice that various reference sources are stated within this section. Then we have lifespan. It states here that the lifespan should be a minimum of 10 years with regular tournament use. Regular tournament use is slightly subjective. What does that actually mean? So the design engineer may need to research that aspect of Tiddlywink tournaments into typical Tiddlywink usage. And of course, the longer the lifespan, usually the more costly the product will be. So we need a lifespan that's realistic for the product we're considering. Section 6.12 is servicing here, and section 6.13 is environment in which the Tiddlywink tester will be used. Page 11, section 6.14 is quality assurance. I've used this section to outline the requirements associated with the process of design and development. They're referring to such considerations as quality assurance program, producing Gantt charts, critical path analysis, ensuring that design reviews are undertaken as the project unfolds. All drawings produced are conformed to the same standard, the reference stated there. The SI units will be used in accordance with the appropriate standard. And I just commented here that where SI measurements are stated, dimensions for weights, etc., the imperial equivalent should also be shown in bracket. Section 6.15 is manufacturing. Some quite generic comments added here, but section 6.15 does refer back to section 6.10, and that sometimes happens within PDSs. We get this cross-referencing. Page 12 has the manufacturing policy. Sometimes it is stated within specifications because the client may want to manufacture as much of the product in-house because that's of financial benefit to them. So sometimes there is a manufacturing policy stated within a PDS. Section 6.17 relates to testing. There are various testing requirements for the final product. Notice here that the impact load is stated in newtons, which is correct, and also in the imperial pounds force. And again, we've got height stated in millimeters and also in inches. And section 6.18 relates to timescales. In this case, they've just stated the final completion date for the design process from where manufacturing of a prototype or a production article can commence. Page 13, section 6.19 is legal requirements. Relates to such issues as no infringement of existing patents shall occur, potential issues if timescales are not adhered to. 620 relates to instruction manual requirements. In this case, it states that the user instructions shall be in English, French and Spanish. Training requirements is 621, and section 622 relates to quantity. It states the initial batch of testers required for the first 5 articles from the batch will be used for prototyping, testing, etc. And as required, appropriate jig and fixture tooling should be used. Page 14 refers to quality control. This is associated more so with the inspection of the product. Section 624, sustainability, a generic requirement. Section 6.25, recyclability, very important considerations for any design we're producing. Disposal, section 6.26, very important to determine how we'll dispose of the final product. Notice that various reference sources are stated throughout the various sections and requirements of the PDS. Page 15, section 6.27, health and safety legislation. Notice there's quite a few references here for the design engineer to refer to and comply with. Section 6.28 relates to CE marking, so European standard or the British standard kite mark. Compliance with these standards is required to sell the product in the European market or the British market. Then section 6.29 relates to the ethics of the engineer. This is essentially requirements associated with the engineer or various stakeholders involved with the design and development of this particular product. Page 16, section 6.30 relates to public acceptance. Again, this is quite an important aspect of any design that's being sold to the public, in this case the Tiddlywink fraternity, and may require the design engineers or certain stakeholders to undertake research using questionnaires, surveys, focus group, etc. to ensure that they are designing a product that's required by the customer and includes features and capabilities the customers would want to see. Page 17 and 18, just notice I've now included the header and the footer on these pages. There's less information to show, so I thought I'll show you that the header and footer are on every page of the document. So page 17 includes section 7, that's the bibliography. These are essentially documents that I've read to help me develop the PDS they're not actually referenced within the PDS, so they're slightly different to references. These are for more generic background information, as is the section 8 here, the list of websites. Again, that's really more for background information, showing some of the sources I may have used to help me develop the specification, but not necessarily the actual criteria that's stated in the specification. So that ends the product design specification for all the requirements all stakeholders need to be aware of. But page 18 and onwards included section 9, which is an appendix, and this is just additional information that you do not need to read to understand the requirements of the PDS, but nevertheless form some background information, and the appendix should be referenced somewhere within the PDS. Here I'm just actually referencing somebody else's website, which is quite comprehensive and gives more information about Tiddlywinks and frequently answered questions. So that includes the overview of the product design specification I'm proposing for the Tiddlywink Integrated Tester. I'm not saying the criteria is definitive in any way here. You may review this PDS and suggest other criteria that should have been added to the PDS or changes to the requirements as stipulated, but that's fine. This is just an example PDS to show you how to apply the structure from our previous presentation. If you do now want to read in more detail the criteria that were stated, I've now got the enlarged version of the PDS for the remainder of this presentation, but it's only for people that are interested in reading the full PDS, as it was quite difficult to read the text shown on the slides in the previous part of the presentation. I'm just going to show you the slides here, and you can stop the presentation and you can read the PDS at your leisure. So this would be the title page. I've shown it broken into two parts here for convenience. As I said before, this contains all the important information associated with the product design specification, and we have our amendment box shown here. This is page 2 of the specification. Notice I am including now the headers on the top of each of the pages for traceability purposes. Page 2 contains the scope of the document. Page 2 continued states the circulation list. Page 3 is the table of contents, full listing shown here. Page 4, section 1 here is the foreword. Note the foreword was generated using artificial intelligence software, as explained here. And note that the appendix is referred to at the bottom of the foreword. Page 5, section 2 is introduction. Page 6, acronyms, definitions. Page 6 continued. Here's a list of references. These may now be out of date, so there might be updated references, but it's responsibility of the design engineer to obtain these references and use the updated references as required. Page 7, this is the main body of the document. Section 6 is the design criteria. Page 7 continued. So here are the requirements under each of the headings. Firstly, performance. Here's page 8, market, materials. Page 8 continued, ergonomics. Aesthetics. Page 9 continued, cost, weight, reliability and repeatability. Page 9 continued, maintenance, and then page 10 commences with health and safety. Page 10 continued, lifespan, servicing. Page 10 continued. Environment. Page 11, quality assurance. Page 11 continued. Manufacturing. Page 12, manufacturing policy. Page 12 continued. Testing. Page 12, timescales. Page 13, legal considerations. Page 13 continued. Instruction manual requirements. Training requirements. Page 13 continued. Quantity. Page 14, quality control. Page 14 continued. Sustainability. Recyclability. Page 14 continued. Disposal. Page 15, health and safety legislation. Page 15, CE marking, BSI kite mark requirements. Page 15 continued. The ethics of the engineer. Page 16, public acceptance. Page 17, bibliography. Page 17 continued. The websites. And page 18 included the appendix. So I hope this presentation has been of interest to you and provided you with insight in how to structure and develop a product design specification. Hopefully you might be able to use this as a basis of your own PDS development. As always, thank you for viewing.